logarithms. You have to say it like you're on the East Coast, I guess. That's how somebody from Boston would say it. They'd say logarithms. So, now what's a logarithm? Well, here's kind of a concept for wanting to get into this whole part of math. Let's say you were trying to solve 10 equals 4 to the x power. Now, give me some way I could try to solve this. Any clues? Have to use a logarithm, you're right. Now, you could take both sides of this equation to the 1 over x power, and you get 10 to the 1 over x equals 4, and I don't have a way of isolating that x. So then logarithms get invented to kind of take care of this. So we're not going to solve this problem right now. We'll come back and solve this one like it in a few days. But here we go with what we'll define as logarithms. Logarithms are the inverse of exponential equations, so they're very related to exponential equations. So if I have an equation y equals b to the x, I have a variable in my exponent, and so I'm going to call this one an exponential. I can rewrite this equation as log. I take that b and I make it a subscript, a little b down here. That b stands for base. When you're writing out exponential equations, if you have a number to a power, that number is called the base. So I take that base and I make that small. And with logarithms, I get to use as the output of that equation my exponent. But I got one more number in here, and that's our letter, and that's the y. So I rewrite this exponential equation. It's rewritten the same way as log base b of y equals x. And so this is in logarithm form. And we'll go back and forth from exponential to logarithm to solve different kinds of equations. Okay? So please note the output of a logarithm is the exponent. Alright, so let's see how that works. If I say 9 equals 3 to the second power, if I want to, that's in exponential form. If I want to write that in logarithmic form, I write log. Now that 3 was my base in the exponential equation, so that 3 becomes the subscript 3 right by the log. That 2 exponent is going to be my output. That 9 is my input. So log base 3 of 9, and you can write the 9 in parentheses, but your book usually won't, equals 2. So log base 3 of 9, if I put 9 into the log base 3 function, I'm supposed to get a 2 out because 3 to the second power equals 9. Okay, let's do another one. So let's say I have, I want to do a base 10 one. So I've got 10 squared equals 100. Okay. So to write this as this exponential in a log form, I write log. What's my base number going to be? The 10. What's the exponent? 2, so that goes on the other side of the equal sign. So what should go in over here as what's called the argument of log 10? 100. Now, if you use log base 10, you don't have to write the 10. No, I often write it just to help me remember what it's about. If you use log base 10, I'll say don't need, and your book won't write it, to write the 10. Instead, we would write log no little base 100 equals 2, and that means log base 10 of 100 equals 2. And this is the one that's in your calculator. So if you just hit that log button in your calculator and put 100 and hit enter, you get 2. Yes, ma'am. It doesn't have to be in parentheses. You don't have to put the argument in parentheses unless you have an addition or subtraction going on inside here. If you had log base 10, 100 plus 7, you'd put the 100 plus 7 in parentheses. If you only have a multiplication, like 2 times 100, you don't even have to put that in parentheses. Yes. You're going to go back and forth today from writing them from exponentials to logs and logs to exponentials. Okay, so let's practice a couple. And why do you have to do that? Because you're going to have to get used to translating these when you solve equations with these. So let's see what we can do. Let's start with an exponential. 2 to the 5th power. Anybody know what 2 to the 5th power is? Okay. Let's write this as a log. Log, do I need a base number here? I need a base number. What's my base? 2. What's the next number I write as the argument to log? Log base 2 of 32 equals 5, the exponent. Okay, let's try going from a log to an exponential. So let's go log base 3 81 equals 4. Did I do that right? Yes, I did that right. Okay. All right. Now we can rewrite that as an exponential. How do I write that as an exponential? 3 to the 4th equals 81. So you need to be able to go backwards and forwards with them. Yes, sir. The only subscript you don't have to write is the 10. Every other subscript you have to write, except for E, but we're not going to do those. Those are